Alright, today we're going to be talking about movements and how to do different types of movements in Unigine. In our example, we're showing a physics-based movement, but we're going to be covering the three main movement types that we have in all types of simulation and video games and all that. So without further ado, let's begin. So there are three types of animation or movement. The first one being the most famous, the instant one, which is like chess pieces going exactly to the spot, while the second one is a consistent movement that you use based on frames, and the third one is a physics movement, which is based on physical frames. So let's go with them in order. So first we're gonna assign our movements on WASD, and we're going to use the normal chess movements where we just move one step forward. So we're just going to use the W button to go forward. We're going to set the movement to go up. Now vector3.forward is the same as saying one step in the y-axis, and we have a log just to make sure. Now we're going to do in all difference, so S being back, and then we're going to take left with the A and right being D. And with that we have our movement for chess, or a step-based movement, or a constant-based movement. Now in order to test it, we're going to check on our little object, and we can see that just by pressing the buttons we can move the object 1 unit in the direction we called. Now in terms of rotation, we're going to be using Q and E, and we're just going to move by 15 degrees whenever we press the button. So checking it right now, as we can see, the movement is going by 15 degrees every time we press the Q and the E button, and the log on the top left corner helps us to see it work. Now what happens if we combine these two? Now as you can see, by combination the movement works perfectly fine and the rotational works perfectly fine. But what if we rotate and we try moving now? As you can see, the movement is not working exactly how we envisioned or planned. So this requires one little tiny change. So from where we were doing with the vector3 forward, we're going to be changing it to getting the position of the object's forward vector, and we're going to be moving it based on that movement. And then for each key or each movement, we're going to be changing the axis that it is alongside the one that we had at the beginning. So after changing it, we do the testing and we see that everything works exactly as we have envisioned, where once we have rotated, we can see that the object is moving relative to the object's forward direction, and the object's movement is uniform too. As for constant movement, what we are going to do is just two small changes. First, we're going to change it to pressed, and we're going to make sure the movement is limited by the frames, so we don't have objects going beyond frame and speed. Then we're going to assign every one of the angles or the axes to their corresponding direction, and we're going to make sure we don't use world direction and rather the object's direction. So by doing this, now we have an object that moves per frame, and it moves at a very consistent pace, thus giving us an illusion of constant movement. And pressing multiple buttons at the same time gives it the movement in diagonal quarters. Now as for the rotation, we're just going to change, instead of going by 15 degrees, we are just going to move it by 1 degree. This makes it a lot easier and frame rateable. And testing that, we can see that the object is moving at a constant rate of 1 degree per frame, and depending on your screen, it works. Now in order to test it, we can see that everything is working exactly fine and it's moving at a constant pace, and just speeding it up around, you can see it's moving perfectly fine as expected. As for physics, before we even start the physics, what we are going to do is actually set the physics up. So in the physics tab, we're going to change the type to rigid, which allows us to have rigid body, and we're going to get a shape. The best shape to use for movement is capsule, so we're going to add the capsule shape, and we have a little capsule shape right here. The next thing we're going to do is go inside and modify some of its tuning. Now this is all up to you, but the main tuning that we're going to do is just change the size just a little bit to give it that little capsule shape. And once we give it that capsule shape, the next thing we're going to do is, for this demonstration purposes, is we're going to limit the angle movement on the X and the Y axes. So it doesn't roll around and it doesn't move around, and the only thing it does is rotate on the Z axis. And by testing it using the physics simulation middle button in the middle of the editor, we can check the object. So just grabbing it up and pressing the play, we can see that physics has been added to our object. Now with the physics added, what we're going to do is we're going to go into our init and we're going to get the body rigid, and then from there we're going to add impulse, and a linear impulse includes the movement impulse. And then after that we're just going to use the forward, back, left, right, and you're going to see that it's going to do the same problem as the chest that we just had at the beginning. But for testing purposes, we can see that the physics works perfectly fine. The push is consistently based as a constant push on an object. So as for rotation, we're going to actually be using the angular impulse. And with the angular impulse, we're going to just use the world direction, which defaults to the Z axes. And then we just use negative and positive Z axes. So this moves it correctly in the Z axis, i.e. moving left and right. So this works perfectly fine. And now when we combine it, as you can see, the movement is perfectly fine on the axes and the objects rotate naturally, but it's not moving how we want it. So the first change, or the only change we need, is to change the forward with the axis of the object into its perspective and its respective directions. After changing that, we can see that everything is now exactly how we expected. The rotation works perfectly fine and the physics works perfectly fine. There's a few fine tunings, but that's up to you and how you like to do it on the physics tab inside the editor. Other than that, everything else works perfectly fine how we want as a movement. So the differences between the two objects is, as you can see in the video, the physics one, or the blue one on the right, is the one that actually gets affected by collisions and all other objects in the game or in the simulation, while the other one is the constant one that doesn't get affected. So there is extra coding for that, but for now we don't really need it. And there you have it, basic movement types inside Unigine. Now for our example, we've been using physics, and we're probably just going to keep it on physics because it's easy to code around with it and I don't need to write any extra coding inside it. Other than that, hope you guys have enjoyed the video and you guys have learned something. Until then, I will see you guys next time. All right, goodbye.